One more I will tell guys. People are joining like a 35, 36, 37 members. After first session or maybe after first part, people will drop. So the guys don't do it. Why? Because middle of the class, either Ruxana madam or Prakash or Revan sir will interact with you. So for giving some information, and also this is a class is to give live class. Okay, we want to conduct live classes. Otherwise, we can send directly recorded videos, right? So that's the point. We have discussed about what is network and what is networking, what is internetwork, what is internetworking. And we are discussed about the different topologies: bus topology, ring topology, mesh topology, and star topology. Next, different type of networks: LAN, MAN, CAN, WAN kind of stuff. We discuss intranet, internet kind of stuff. In the part of intranet and internet, I explained this small home, small office, home office kind of concept. So here we discuss about certain devices, hubs, switches, routers, wireless access point, and modem kind of stuff. And a small point about a default gateway. And what is our Wi-Fi router will do, what can it be able to do, and I given this work. Okay. So today, we'll continue the last part like a devices. I given one point for each device, but I will tell one by one a few things. Okay. What is the today's date? 09/02/2023. So we'll discuss networking devices. There is several devices are there, guys. For example, you can take a hub, repeater, which bridge. What happens? Router, modem, modem. I said no, wireless access point, wireless access point. Deep CE, DTE equipment is there. CSU, DSU is there. Firewalls, firewalls, checkpoint servers, IPS, IDS, and IPS, intrusion detection system, intrusion prevention system. Means someone trying to enter into your network. So what is this IDS, IPS will do it? It detects any unauthorized packet is came without knowing to use. Okay, so it will detect any packet is came without asking that one, right? Okay, so unauthorized packet is came into your network, it will detects, and it also prevent to not to enter into the main network. Okay. Okay. Not only this, there is so many other networking devices also there. Point, both software servers and hardware parts also available. But I'm not going to discuss all of these things. We are going to discuss about a hub and mainly switches. Of course, for repeater also we'll discuss router and a modem only. Wireless access point already given one line, that is enough, so I'm not going to tell more about it. Just like how I told about a one point about a devices, same way, first we'll okay. This is single line points only, but there is an explanation Okay, there is a multiple lines explanation is there. So we will discuss that. Okay. Here it is hub. Hub used in a LAN communication and suitable for a small network. It's not much intelligent device it is. It does not understand IP MAC address kind of concepts. Okay. Hub is a used for LAN communication and small network means 2 or 3 computers are okay. Repeater is a device. It repeats the signal so then we can communicate it to longer distances. Switch is a device is used for LAN communication. Like a hub, switch is also used for LAN communication, but used for a small and large networks. Switch understand MAC address. Okay. Router. Next one is the router. The router. Okay. The router used in both LAN communication and WAN communication. Router is a inter-networking device. It shows best path to reach the destinations. Next is a modem. Modem used to connect to the internet using telephone cable or a fiber optical cables. Using telephone cable or a fiber optical cables. Optical fiber cable or a fiber optical cables. So just one line I need it. So that's why I am adding this. Okay, these are the different devices. So one line answer or one way you can want to tell, so we can tell. But we are going to discuss one by one. First one is what is hub? Okay, hub. Hub is a not a intelligent device. Hub is a not a intelligent device means it does not understand what is a MAC address, IP address. This kind of concept you don't understand. Okay. It works for a LAN communication. It is suitable for a small area. Small. It is suitable for small networks. It is suitable for a small networks. Hub is a layer 1 device as per OSA layer. OSA is a reference model open system interconnected. It is a reference model. It contains a 7 layers. It's a kind of networking model. To communicate from one system to another system, we are communicating, right? You are accessing a website, you are sending a mails, okay? You are uploading your files, downloading your files. So we are communicating from your PC to the remote PC. Okay, so you are sending as well as a receiving, right? So how your network is sending, how you are sending, how you are receiving, the totally how many layers, I mean totally within the 7 layers, the how communication is happened to understand it, so we can understand it. We use OSA layer study. It's only for study purpose. Okay. So in that OS layer, 7 layers, the first layer is physical layer. So hub is almost example for a layer 1 device. Okay, it's a physical layer. It does not understand MAC address or IP address. These points are not really required. Okay. And here it is, it shows it broadcasts packets to every device in the network. This is how hub is look like. ఏదన్నా పర్వాలేదు కాఫీ ఉంటే సైజ్ సరిపోయింది పక్కన. Okay, this is a hub. Okay, it contains the ports. Just we have to connect our computers or a laptop through the wire. We can able to connect it. Outside. AC open kar. It's okay, sorry. It's trying to open the door, but it is become inside out. Okay. Guys, here try to understand how this hub works. Hub inside it's a simple switchboard type only. It is not having any other. This is our hub. So devices are connected to hub. Okay, directly with a cable. You want to see how it is connected, so then also we'll try. These are giving images, not that hubs, not PC hub, but switch connection. This is USB. Who said USB had to say I want a network hub? So this is how network hub is there. So look like, and if any case. ISP stand for Internet Service Provider. Internet Service Provider. Yeah, we got it. Guys, this is the hub. Okay, so we are connecting with the cables like this. Another end of the cable is connected to your laptop or a desktop. Okay, these are the different symbols of network related symbols, how it is look like. Okay, not exactly, but it's okay to understand. This is a hub, so devices are connecting to this hub. Hub has a ports like a port number 1, port number 2, but they don't have any particular value. It is in a hub, there is no MAC address understanding, IP address understanding kind of stuff won't be there. We take port number 1, port number 2, port number 3, 4, port number 5. Think like this. This is a APC, B, C, D. Okay. Port number 6. Like we have a ports. A is connected to port number 1. B is connected to port number 2. D is connected to port number 4. B is connected to port number 5. Okay, it is not required to follow 1, 2, 3, 4 order, right? just for our understanding. So A want to communicate it to B. It is A to B communication. So look at here. A send a packet, is sending a packet to B. Okay, A is sending a packet to B. So first packet will go to port number 1. And the packet is now going to CPC and DPC and BPC also. Packet is going to BPC, DPC and CPC also. So everyone will get a packet. Send packet. Packet means like a communication, send something. Send packet from A to B. Send a packet to A to B. Packet goes to hub to A, sorry, hub to B, C, D. If you have any other devices, it's sent. So packet is sent to every device in the network. Packet will be sent to every device in the network. Packet is sent to every device in the network. So this is one of the important point for a hub, guys. It broadcasts packet to every device in the network. So what will happen if you broadcast? If you broadcast, we accept the packet because that is the destination. Remaining drop the packet. Remaining devices drop the packet. So what will happen if you are sending a packet like this? So what will happen? Consumes more bandwidth. Consumes more bandwidth. Number of collisions occurs. More packet data loss. More number of collisions and more packet data loss. Okay, so that's why it is suitable for a small networks. That's why it is suitable for a small networks. Again, guys, what is a hub? Non-intelligent device. It's not an intelligent device. It does not understand IP address or MAC address kind of stuff. We use for LAN communication, suitable for a small networks. It is a layer 1 device. As per OSA layer, it is a layer 1 device, physical layer. It broadcasts the packets to every device in the network. Okay, so when you are sending a packet from one machine to another machine, so it broadcasts the packet to everyone. So this is a repetition, right? It happens always like a B2C. Packet sent to A, C and D. D to A. Packet go to A, B, and C also. So what happened? So it become a more number of traffic increases. Traffic increases hub consumes more bandwidth and more traffic also at hub. And number of collisions, more number of collisions occurs, and it go to more data loss. So that is the point. Here I put a heading repeater. Guys, understand or not? What is a hub? What is hub?
Sir,
Yeah, tell me.
sir, more number of collisions occur means
Same place, different data, same path, a lot of packets are traveling in a same hub, lot of packet and unnecessary packets also running, right? So I want to send a packet to B, but same packet to go to C, D. Simultaneously, other packets also traveling in a same path. So what happened? So there is a confusion, there is a collision will occur because a packet is not a virtual thing, right? It is a electronic signal. Okay. So then it's possible that the packet may be corrupted because of more number of packets traveling in a same path.
but the other packets will drop the no.
When they received
Yeah, yeah,
and understand when they received, she received already received, and it will check it is not belongs to me. I will drop the packet.
yeah, yeah, yeah.
Okay,
Yes, sir. Thank you.
very good, very good. So you're listening. Good. So repeater repeat the signal. So then signal can send for a longer distances. Here one point is there is a cable called a twisted pair cable type. I will tell twisted pair cables again. Cables UTP or STP. It support only 100 meters. 100 meters. It means you want to communicate more than 100 meters. You need a hub. Sorry, you need a repeater. If want communicate communicate more than 100 meters, need repeater. This is one example. So you can use hub as a repeater. You can use hub as a repeater. Okay,
Excuse me,
but
sir.
yeah, tell me.
What is UTP and STP?
Un, unshielded twisted pair cable, shielded twisted pair cable. The cable, our LAN cables are there now. That is the cable. Okay. So again, I will tell about that one in a cables. So after this one, we will discuss about the cables that we will see.
Okay, sir.
Okay. So how this repeaters are look like. So repeater in the computer networks is look like different ways. Okay, this is with the coaxial cable. This is UTP, STP cable type. Guys, repeater is not going to boost your signal. It's not going to boost your signal. It repeat the signal. Your strong signal is there, and the signal become weak after certain distance. You use a repeater The repeater repeat the signal. It don't boost the signal, it repeat the signal. So then you will get to go with the longer distances. So this is a one easiest example. It's a good diagram. We got it now. Okay. And also you can see another. This is the one I'm trying to find. Okay. This is a hub and this is a repeater. How it is look like. So repeater means one input we are giving here and there is an output. That's it. It's not like a hub. Okay. It's not like a hub kind of stuff. Another example is your Wi-Fi extender. Okay. So you have a Wi-Fi network at home or in an office. What the people will do, they will put in a one corner of this Wi-Fi router. And I may be near to this. Okay, so we will get a signal, right? So this is the range of signal it is. Okay, these blanks are just because of my mouse error. Okay, it's not a blanks, guys. It is mouse error points. Okay, do not think I draw wantedly. Okay, so the signal may weak once it is reaches to certain place, right? I have a mobile phone or a laptop, something which we cannot able to get full signal or maybe no signal kind of stuff. Okay, so what it is better to use in middle a Wi-Fi repeater kind of stuff. It is a Wi-Fi repeater or a Wi-Fi extender. What it will do, it take a signal from you and repeat the signal and send it. So then I can able to receive a signal. I can get a good signal to my device. This is the Wi-Fi extender. So just we missed somewhere. Yeah, this is the Wi-Fi extender. Why we should know all these things, guys? If they are going to ask question, no one knows
It
what it
also called
is.
a route.
It is?
We also called it as a router, Wi-Fi router.
Yeah, it is not. Sometimes this Wi-Fi routers also available in these sizes. Okay,
Yes.
your Wi-Fi router in our home. Yes, very good. We have a home. In our home, we have a Wi-Fi router kind of things. Sometimes in your home you are there, but you are one in your room you are not getting good signal recipient. So what you will do, you'll better to buy a dual channel Wi-Fi extender. So you'll receive a signal from your Wi-Fi and you will catch it. No such special configuration is not required. Okay. So again, you need to connect to Wi-Fi repeater, not required. So simply it bypasses that point. So when you connect it to main Wi-Fi, that is enough. Okay. This is a Wi-Fi extender. It is useful, guys. What are the things available in your surrounding currently useful kind of stuff? You must know it. Okay. How it works. Okay. What is the use? Where we use this kind of stuff is helpful. So this is a diagram. I can't able to see my screen. So maybe too much brightness, it is too much light color. So this is internet connected to this Wi-Fi router, but computer are located in different locations. So signal cannot be catched. What they do, they use a repeater here so they can able to connect it. So there is a big lengthy pictures also there. Yeah, this is one of the example. Another example. Even for a LAN connection, it is also work like a wireless access point. It's not like a wireless router. You are already having a wider router is there, for example. So you don't have a Wi-Fi router. You can use this one as a wireless access point. Okay, you can use wireless access point also. Yeah, this is about your hub and a repeater. Okay, guys, do you got? This is the PPT which is I prepared, and some data I have typed, some data I have collected. Sometimes I don't arrange properly, so that's why I'm changing things. Guys, switch is an intelligent device. It understands MAC address, understand MAC address, which is not given, so we'll have to type that one. Understand MAC address. I didn't told you what is MAC address. I think so. We'll discuss that one also. We can understand. It will understand a MAC address. MAC address is nothing but a physical address. Every NIC has a MAC address. So I will tell that one. So don't worry. It understands MAC address, not IP address. Understand only MAC address. It maintain a MAC address table. It maintain a MAC address. Views search in a use switch in LAN communication, like a hub. Switch is also used in LAN communication. We works in both large and small networks also. It is a, as per OSI, it is a layer 2 device. It is a layer 2 device. We can connect a large number of devices to the network. Large number of devices we can use in the network. Of course, guys, hub and switches both are using in a star topologies. This is not a concept, it is, and this is also not sure about it. Full duplex, half duplex. Okay. Of course, there is so many points we have to add. So this is how the switches look like. One second. This is how the switches. Okay. So can you see there's a lot of ports are there on the search. You can see a lot of number of ports are there. Okay. So means you can connect number of devices. Of course, in a star topology, we have extended star topology. Means one switch is connected to another switch. So then one switch is connected to multiple devices, other switch is also connected to multiple devices. So both are connected means it is become a larger network. So it is switch is used in both small and large networks. We can use it. It is a layer 2 device, works for LAN communication. It is used for a LAN communication. It understands MAC address. It maintains MAC address table. Okay. Here is one story is there, guys. That's why I added this part. Point is switch initially broadcast packets to every device in network. Of course, like a hub. Like hub. Okay, like hub, it broadcasts packets to every device in the network. And we can put our switch here also. Okay, or maybe you can put this into upside. No balance is learn MAC address of the device connected to the switch port. Learn the MAC address of the device connected to that switch port maps MAC address that MAC address to switch port number. I will explain it, guys. Don't worry. What is this underline? I removed it also. Okay, switch port number. So the map we call it as a MAC address table. Okay, we call it as a MAC address table. Next. Okay. Switch unicast packets to destination device using MAC address table. So this is what it is happens in our search. Okay. I am doing some drawing. If it is a paintbrush, for me it is very easy. So same how hub is connected, same way we are connecting this one. So we use a hub. At this time we are using a switch. example, I have a 8-port switch, but I have 6 devices, no problem. So we have a 8-port switch there. I like paintbrush. Okay. It is always best to go to 2. You go to 3. This is going to 4. And this is going to 6 and 7. Distance is important, right? Okay. So guys, this is A, B, C, D, E, F. So these are the devices are connected. You can make it smaller also, no problem. Okay. What is this device? Centralized devices. We are using switch. Okay. Now I'm sending a packet A to B. So initially it work like a hub. It send a packet to everyone. So packet first it goes to switch. Switch don't know where is B. Switch don't know where is the BPC. Where is the BPC? So what will happen? So switch don't know where is B. Where is B? B1. Don't worry, what is that? I will tell guys. Every device is connected to the network through their NIC, network interface card. So every device has means their NIC has a MAC address. Just for our understanding, I'm writing a MAC address here, A1. For this one, I'm writing a MAC address is B1. Okay, writing this MAC address is C1, this PC MAC address, not PC MAC address, this PC having a okay. So APC, BPC, CPC, A1, B1, C1, D1, E1, F1. These are the MAC address of that NIC. So actually I have to tell that one NIC, but I'm trying to continue these devices. And this will little bit problem, but remaining is okay, normally one only, because switch is having a MAC address table. So compulsory I have to explain you. Okay, so that's what I'm telling. So A send a packet to B, then packet is goes to switch. Switch don't know where is BPC with their MAC address. So where is BPC, APC? There is no APC, BPC. Switch understand devices by their MAC address. Okay, their MAC address. So it send the packet sends to everyone in network. Okay, everyone in the network means every device to everyone, to every device in network. Every device, that's you understand already. Okay, so then what will happen? Then what will happen? In search, then yes, MAC address is A1. So what is A1? It lengths 1 and maps to port number 1. Where it is connected? Port number 1. This port number 1. Okay, so I will draw the MAC address table separately. This is guys MAC address table or a MAC table. MAC address table or MAC table or MAC address table. So here it is. First one is MAC addresses of the devices and switch port numbers. Switch port, physical port numbers. Okay. So what is the first thing I learned? There is a A1. A1 is a port, MAC address and switch port number is 1. Okay. It's a big story it is. So another example, for example, DPC send a packet to MAC is a permanent address. Very good. MAC address is a permanent address, physical address. Okay, we cannot change the MAC address. So you want to send a packet to something E. Okay, same packet goes to okay. Packet goes to switch. Switch don't know where is EPC. So E's MAC address is E1. For example, just for example, guys, A1, B1, that kind of IP MAC address won't be there. So what it will do? So packet broadcast to everyone, every device in the network. Okay. Next. In switch, what happened? In switch, it learns his MAC address this even it maps to your switch port number 1. Where is the is? Is connected to 6. Okay. Like this, switch creates runs MAC address of devices and create a MAC address table. Think like this. It is keep happening. Okay, it is keep happening. BPC, for example, in this case EPC, E1 MAC address where it is connected 6. P1 MAC address and which is connected to port number 2. CPC, same way, while they are communicating, so switch automatically recognize these devices. E is already done, D is there, D is connected to 4. F, last one is F, is a device connected to 7. So like that, so when system is, there are communicating each other, when they are communicating each other same time, switch is trying to learn the MAC address. Same time, switch trying to learn the MAC address and map it to a port number, switch port number. So that we call it as a MAC address table. So what is the use of creating this MAC address table? What is the use? Somewhere you should use it, no? So what is the use? Once it learn the MAC address table, it start unicast. For example, MAC address table is done. Okay. For example, A want to send a packet to E1. E. What happened? Packet goes to search. Packet go to search. And E1, because EPC, right? E1 is at which port number? 6. Switch port number 6. So packet send to port number 6 directly. Where it is gone, it's become very big node now. Okay. If you want, I will explain once again, no problem. You can't
Please
put here.
explain it, please.
Yes, sir. Please explain it again.
I will do it. I will do it. So don't
One more.
worry.
Yes, sir.
Okay. So I will explain here because here we will get a lot of colors. Okay. So do not worry, guys. It's like they will ask questions in interview or not kind of. But this concept is very useful for you both in a troubleshooting time and as well as like you want to go through the networking related kind of stuff. This is very useful. Okay. But whatever it is, we are learning means you should learn everything. Think like this. This is APC. this is a NIC which we are connecting. So I will show you my NIC. Okay, so my NIC, my network card. So I'm currently connected with wire, of course with wirelessly also. So this is my wireless adapter and this is my wired adapter. Both are connected because I'm in a single room. Okay, here in our office we have both connectivities there. So this is the Wi-Fi adapter details. This is the physical address, means my MAC address. Even Wi-Fi adapter or wired adapter, so you can see their MAC addresses. This is the wired adapter and this is their MAC address. This is how MAC addresses look like. Okay. Now every NIC having a MAC address. Example, easy to understand. I put A1 for a APC, B1 for BPC, C1 for a CPC, D1 for a DPC, E1 for EPC, F1 for a FPC. Now you need to take those on things. And each switch, their port has a port number, right? Hub or a switch, the port is there, the port is having a port number. For example, this is a port number 1, port number 2, port number 3, and there is a port number 4. This is port number 5, port number 6, port number 7, port number 8. So these two are not connected to anyone. So simply 6 devices, 8 ports it is. Think like that. Now first is A to B. First is A to B. You want to send a packet to BPC, A to B communication. Packet is going to port number 1. To the switch, to the port number 1. Okay. So while you are sending a packet, you'll send in your packet, you have a yes MAC address, yes IP address, source IP, destination IP, B's MAC address, and B's IP address. The packet contains source MAC address, destination MAC address, source IP address, and destination IP address. Okay. So the switch don't know where is the B's MAC address. What is B's MAC address? B1. What is A's MAC address? A1. Switch don't know where is the B1 is connected. So what it will do? It broadcasts the packet to everyone, just like a hub. So what other devices will do? They drop the packet, B1 accept the packet. Meanwhile, at search, what happens? There is a MAC address table will created. So I will write right here a MAC address. So mouse column, missing column, we don't understand. MAC address. Okay. So first one is your MAC address. And next one is your switch port number. Okay. So what it will learn from source packet like A1. So it will put a A1 here and port number is 1. This part done. Yes, understand first one. You have to understand step by step. Okay. For example, I want to send a packet from this is yellow color. It is not even. This is good somewhat. E to CPC. What is E's MAC address? E1. What is C's MAC address? C1.
Even.
Okay, very good. Send packets sent to this port. Which port it is? Port number 6. Okay, and where is the C1? Where is the C1? As per MAC address table, we didn't learn it. We didn't learn. Okay, so what will happen? We'll go to broadcast to everyone. What will happen? We broadcast to everyone. Of course, he accept the packet. At switch, what happened? E1 is connected at port number 6. Okay. Similarly, so when any device like a C send a packet to someone, D send a packet to someone, B send a packet to something. While they are communicating, we learn their MAC addresses and map it in the MAC address table. Like a C1 is connected to port number 3. D1 means D device is connected to
Sir,
port number
sir,
5. Yeah, tell me.
sir. So what is the use of IP address?
Currently, we are not in the IP address mode. Okay.
Yeah, yeah.
Here, IP and MAC both are there. But switch understand MAC address, not IP address.
Yeah, yeah, no, I was asking that one only.
Yeah, okay. But we are communicating. This is I am telling what contains in the packet, but we are communicating with the IP address only. Okay. F1 is connected to port number 7. Like this, my MAC address table is created. My MAC address table is created. Just for example, now A want to send a packet. A want to send a packet to D. A send a packet to D, right? First it will go to port number 1. A packet is go to port number 1 to the switch, and switch will check where is the D's MAC address. It's a D1 MAC address, and where it is connected, port number 5. So then it will send directly to the port number 5, and D got a packet. Now broadcasting is stopped. Okay. This is simple to get it, guys. Just for example, it's not really a correct example, but still I'm telling. First time you don't know address. What you will do? There is 100 apartments, 100 houses are there. Not 100 houses, it's like 50 houses, 100 houses. Initially, you don't know where it is located. Okay, exactly what is the number. Okay, which house it is, which apartment it is. So what I have to do?
To go in each and every apartment to check the right
We have to
address.
go to each and every apartment.
Each.
So then you know now. You are noted down. So this is the place. You have a correct location. Now you got this point. Okay. So what we do? No need to check second time, right? You have a list. This is the place. This is the door number. This is the address. This is the door number. This is the address. You have to go there. So you check the door number and go there. So no need to send to everyone. Okay. So this is not a correct example. Just I am trying to convey.
So here, sir.
Yeah, tell me.
So here you try to say that if we in MAC address problem, if we know the port number and MAC address, then we have to know doesn't know to know another thing.
I didn't get it, but okay. Here, Ambika also put a question, so that's first I will tell. Switch behave like a hub, yes, of course. until unless it is complete the MAC address table. That is no. Okay, so maybe first it will check the MAC address table. In MAC address table, it contains the information. For example, this data is still not there. Okay, see this F1 data is not there. Okay, C1 data also not there. Only A1, APC, EPC, DPC data is there. Same scenario. A to D communication. It will happen. First, it will check the MAC address table. Where is the D1 is connected? Where D1 is connected? 5 send. Okay. For example, this is my MAC address table. In the same time, what happened? B want to send a packet to C1. C. B send a packet to this. So then B1 MAC address table is created. B1 is connected to port number 2, that is will be created. But where is the C1 record? C1 record is not there. What it will do? It broadcast. It do broadcast. What is the advantage of this MAC address table? Number of collisions will reduces. Okay, number of collisions at domain level means at entire switch don't get a collisions. Only port wise collisions will happen, but entire collisions will be reduced because you are not sending to everyone. Okay, think like this, guys. You are a person. You got letters, right? You are getting the letters. Some letters are belongs to you. Some are not belongs to you. So what happened? Okay, belongs to you is okay. Not belongs to you, what you will do? You have to drop the packet. You're dropping the packet, but you are accepting it, right? Like you have a post box. Think like there is a post box. Your packets are 2 packets, but you are getting a more post in that one. Is it more traffic at your port, right? More traffic and not unnecessary data will create it. So that's a switch is reducing that one. You are getting your packets only. You are not getting someone's packets once its MAC address table is used. Okay. Within a seconds, within less than a minute itself, a MAC address table will be created completely. Okay. Now new switches very easily created. Okay. So this is simplicity telling about a simple way to tell MAC address table, guys. So switch will learn the MAC addresses of devices. Switch learn MAC addresses of devices and map to their port number. When packets are sending and receiving time, they check the MAC address table. If destination port is destination device MAC address and port number is available, it send packet to that one directly. If destination MAC address and their port number is not available here, the means switch port number is not available here, it send the packet to everyone. So what is the advantage of using this one? It reduces number of collisions. Plus packet data loss. Okay. Yeah, one point I didn't add here and here. So maybe people like it or not, we don't know. Let it. Add here. Switch is single broadcast domain. And single collision domain means collisions will occur at hub, so that's it is called as a single collision domain. This is gone too down. That's it. Okay, but switches single broadcast domain. You are broadcasting within the switch only. That's it. Okay, but it's a multi collision domain. Okay, guys, this is the difference between hub and switch. So I'm taking for two power. It's a lot of time now. Hub is a non-intelligent device. HUD does not understand MAC address and IP address. Hub used for LAN communication. Hub is suitable for a small networks. It is a layer 1 device, physical layer as per OSI. Hub broadcast packets to every device in the network. Okay, and next switch. Switch is an intelligent device. It understands MAC address table. Okay, it understands MAC addresses and learn MAC address. MAC address table. It maintains the MAC address table. Switch used in a LAN communication. Switch is a layer 2 device, and as per OSI, it is a layer 2 device, means it's a data link layer, OSI layer. We can use in a small and large networks, means large number of devices we can connect it. Number of collisions are less, so less packet data loss. So that is already covered there. So I will go in this one. Switch initially broadcast packets to every device in the network like a hub, but it learns MAC address of the devices are connected to switch port number. Okay, once it is learned switch learn the MAC address of the devices which is connected to that switch port. It maps that MAC address to the switch port. It is called a MAC address table. Switch uses this MAC address table to unicast the packets. Okay, if the destination device MAC address is available in a MAC address table, okay, and their port number, so packet will be forward to that port number only. So that is what I am trying to say. Switch is a single broadcast domain and a multi-collision domain. And guys, this is a one small point I'm adding here. There is a L3 switch. Switch is a L2 device, layer 2 device. OSI layer 2 device. So we will know when we are talking about OSI layer part. Okay. So switches, there is a L3 switches also there. Actually, layer 3 device is router. Layer 2 device is switch. Layer 1 device is hub. But there is a layer 3 switches also there. What is this layer 3 switch? It functions as a switch functionality and routing functionality. Routing and switching, both functionality is able to do it, both routing and switching. What is comes under switching, like a VLANs creation, inter VLAN routing. Okay, so switch functionality is a LAN, VLANs, LAN, inter VLAN communication like that. Okay, so router is used to inter VLAN, switch is for VLAN. So this is L3 switch will do both the things: VLAN creations, inter VLAN routing, VTP communication, inter-network communication also happens with that one. What I have taken only one day, one class. What happened to your batch, guys? Only one class, one day, one class, one part. It is too much delay. All good for me.
Sir, other class will start tomorrow.
That is communication class will start tomorrow.
Yes, sir. Started from tomorrow.
Tomorrow 4 p.m.
We got the notification.
Yeah, you got it. No? I've seen morning. I've seen that.
Yeah, yes, sir.
Actually, yesterday evening, I added one assignment in Google Classroom.
Yeah, yes, sir.
Yeah, now it's opening. Okay. I added one assignment. So Manish Yadav done. Son
Yeah,
of
yes, sir. I did it.
Sir, I submitted.
very good.
Sir, yeah, already submitted, sir.
I will do it today.
Okay. So do it by evening, guys. So I will trying to it, and also already I shared this link to you. Okay, how to connect. Otherwise, I will send again copy invitation link. Alright, you can go to simple Google Classroom link. It is there. So I will share it separately because it's in a recording mode now. Once class completed, I will do it. Guys, take a just 5 minutes break. Okay, because I am also telling some much stories. You may forget what we have discussed also. So just I stop recording. Router and modem is